This is our 6.5 video, or our video for solving rational functions or rational equations. So we're going to start out with some review, and then we're going to get into the actual solving of rational equations part. So for this first problem, remember this is a compound inequality because it has two inequalities in there. And we want to solve it by basically doing the same thing to all three sides. So remember, this has the left side, the middle side, and the right side. So, and we're trying to isolate the x in the middle. So we want to do minus 5 to all three sides. So we get negative 9 is less than or equal to 2x, which is less than 5. And then we want to divide all sides by 2. And so we get negative 9 halves is less than or equal to x, which is less than 5 halves. Then remember, we want to write our answers into two forms. In set form, we would say x is equal to the set of all x values such that, and then we write our compound inequality solution here. So negative 9 halves is less than or equal to x, which is less than 5 halves, and then close our set. Or we can write it as an interval, which goes from the least value to the greatest value. And when it's a compound inequality like this, basically we've got this all set up where this is the least and this is the greatest. And so we just set that up of negative 9 halves, comma, 5 halves. And then we have to decide if it's going to be parentheses or exponents. So, sorry, not exponents, parentheses or squared brackets. Negative 9 halves gets a squared bracket because it's equal to, and 5 halves gets a parenthesis because it's not equal to. Okay, now this is a review of what we've been doing earlier of simplifying rational expressions and also finding our critical and restricted values. So remember, step 1 is to factor. So we're going to factor all of these. So I'm just going to set up my, this one's a difference of squares, so I know right away that that one is going to factor to 3x minus 2 and 3x plus 2, those conjugates right there. So this first diamond problem is going to be for the first numerator. So factors of 16 that add up to 19. That's 15 and 4. So this is going to give me 6x plus 15 and 6x plus 4. Divide this one by 3, divide this one by 2. So my first numerator is 2x plus 5 times 3x plus 2. That's what it factors to. All right, now this next one is going to be my first denominator. So this is factors of negative 10 that are going to add up to 3. This would be 5 and negative 2. So we got 2x plus 5 and 2x minus 2. Divide by 1, divide this one by 2. So my denominator, my first denominator, factors to 2x plus 5 and then x minus 1. And then it's multiplication, so we'll go ahead and put that c dot in there. And then finally, this is going to be our second numerator. So we're looking at factors of negative 30 that add up to 13. This would be, you would think 10 and 3, but because it's a negative 30, we have to go with 15 and negative 2. So this is going to give us 3x plus 15, 3x minus 2, divide by 3, divide by 1. So our second numerator becomes x plus 5 and 3x minus 2. Okay, step 2, we want to find restricted values before we simplify any of these. So we're going to do 2x plus 5 cannot equal 0, x minus 1 cannot equal 0, 3x minus 2 cannot equal 0, 3x plus 2 cannot equal 0. So this gives us x cannot equal negative 5 halves, x cannot equal 1, x cannot equal 2/3, and x cannot equal negative 2/3. So again, we want to go from least to greatest, so this would be overall x cannot equal negative 5 halves, negative 2/3, 2/3, and then 1. Alright, so that was our second step. Our third step is to divide. So we're looking for things that will divide out. So the 2x plus 5 will both divide out. The 3x minus 2 will both divide out, and then we have 3x plus 2. Both of those will divide out, so we're left with x plus 5 over x minus 1, and again with these critical values listed as our final answer. All right, let's get into solving rational equations. So solving rational equations, basically, you want to know what is the difference between an equation and an expression. Basically, an equation is two equal expressions. So we have some kind of mathematical expression on both sides of an equal sign. Why can we do certain math strategies to an equation that we cannot do to an expression? It is because of the what is equal. So with an expression, really all we can do is multiply by the value of 1 to a term, or something that equals 1 to a term, and combine like terms and factor. And that's basically all we can do. But with an equation, we can add the equal amounts to both sides. We can divide both sides by something. We can take the square root of both sides. So there's a lot more that we can actually do to an equation. So then finally, if we're trying to solve for x, what it is in the denominator. If we're trying to solve for x and it is in the denominator, what do? Well, we have to get x out of the denominator, so we multiply by x to get it out of the denominator. Okay, so one thing else that I'm going to add in here that's really important when we're solving rational equations, I'm actually going to type this instead, so let me switch to my keyboard. Okay, so when we're solving rational equations, we want to rewrite the rational equations as a polynomial. So then we already know how to solve a polynomial. We factor it and have it set it equal to 0 factor and use the zero product property. So that's the big thing. So what we need to do to be able to change all rational equations into a polynomial is we need to multiply by the denominators to get rid of the denominator. Because remember, we can't have x in the denominator because that would indicate a negative exponent. And the exponents for a polynomial all have to be 0 or positive integers. All right, so let's go ahead and move on to this next problem here into actually doing this. So this is an example of a a rational equation, because now it's equal to 10. So a lot of this still comes around to, hey, let's factor. So we're going to factor all of these, and if you notice, this is the exact same thing we already factored and we simplified. So this was what we did back in our first example problem, and remember that simplified to x plus 5, that's not 5, sorry, over x minus 1, as long as x does not equal negative 5 halves, plus or minus 2/3, and 1. Okay, so this is what we simplified to it, and now we're going to set it equal to 10. All right, so once we simplify our rational expressions, which is what we should go for every time we see a rational expression, we should go for doing that. Now what we want to do is we got to multiply by the denominator to get it so it's a polynomial. So we're going to multiply this entire rational equation by the denominator of x minus 1. So when we multiply it over to the left side, we're just left with x plus 5 because x minus 1 divides out. And then when we multiply it to the right side, we have 10 times x minus 1, or 10x minus 10. So our equation is x plus 5 is equal to 10x minus 10. And then we can solve for x in this case. So because it's linear, we don't really have to worry about it being equal to 0. But if this was a quadratic or cubic or any other exponent, higher exponent or higher degree than 1, we would have to set it equal to 0. So because this is linear, we can just go ahead and isolate the x. And so we get 15 is equal to 9x, divide by 9. So we have 15 over 9, which reduces, if we reduce both by 3, we get 5/3 is equal to x. And since 5/3, our solution, is not one of our critical values, that is our answer. And so that's why the critical or restricted values are so important, because we want to make sure with rational equations that we do not get the answer that is a critical or restricted value. All right, so now let's look at another example, ones that we haven't already factored. So if you guys look at this, the one on the left is already factored because everything's linear or constant. So in the case on this problem, we want to get rid of the denominators, so we're going to multiply both sides by 3 and by 5. So when we multiply in here, the 3 divides out and we're left with 5 times x plus 6. And then when we multiply it to the right side, the 5 divides out and we're left with 3 times x plus 8. And so we're going to do the distributive property here, and we get 5x plus 30 is equal to 3x plus 24. Then we're going to solve, isolate the x, because again, this is a linear on both sides. So we get 2x is equal to negative 6, divide by 2, and we get x is equal to negative 3. Now remember, on this problem, because we had constant numbers in our denominator, there was actually no restricted values or no critical values, so that's why we didn't find those. So there's our answer right there. Okay, now on this one, does not factor. We can factor this one, does not factor. So we're still going to have y over y plus 3. And then the second rational expression becomes 2 over y times y plus 3. And then we have 6 over y. Okay, so on the case of this one, the individual rational expressions do not simplify. So now we're going to go right into multiplying by the common denominator, like we did with complex fractions where there were multiple fractions. So if you look at this, if we think about our common denominator, the first two fractions have y plus 3 in common, and then the second two fractions have y in common. So that's our common denominator right there. So we're going to multiply this into all three terms, and we're going to get rid of the denominator. So the y plus 3 is going to divide out, and we're going to be left with y times y. The y and the y plus 3 will both divide out, and so we're just left with the numerator 2 is equal to, the y will divide out, and we're left with 6 times y plus 3. So now we've got y squared plus 2 is equal to 6y plus 18. Okay, this is a quadratic, so we need it to be equal to 0. So we're going to subtract the 6y and the 18 over. So we got y squared minus 6y, and then 2 minus 18 is going to give us negative 16 is equal to 0. So now we're looking for factors of negative 16 that are going to add up to negative 6. That would be negative 8 and 2. So this becomes y minus 8 and y plus 2. Remember, we go right in there when there isn't a leading coefficient for the quadratic term. Basically, we just take the numbers that we found and go right into our parentheses. And then we're going to use the zero product property. In this case, we don't go and say it's not equal to, because we're actually trying to solve it. This is not in the denominator. So we get y is equal to 8, and we get y is equal to negative 2. So we need to double check here and make sure that those are not from our critical or restricted values. So we go and look at our original denominators, and we had a denominator of y, so y cannot equal 0, or a factor of y. And then we had an original factor of y plus 3. So y plus 3 cannot equal 0, which means y cannot equal negative 3. Neither one of those are our answers, so there's our solution right there. Okay, so basically, here you go. Steps for solving a rational equation: factor and simplify individual terms. Okay, so that means if it's being multiplied or divided, go ahead and simplify those rational expressions together. But anything that's adding or subtracting, that means that there are those are terms, and you're going to only simplify them individually. And then you're going to multiply by the denominators, common denominators to be more specific. And then you're going to solve the equation, which is a polynomial equation. And then finally, you want to make sure your solution includes any of, make sure if your solution includes any of your critical values that you eliminate them from part of your solution, so you don't include them as your final answer. So just to go over it again, steps for solving rational equations: you want to factor and simplify, and you simplify the individual terms. Then you want to multiply by the common denominator, and then you want to solve the now created polynomial equation, and you want to make sure that your solutions, if your solutions include any of your critical values, that you eliminate them from your final solution. And so that is 6.5. So we're going to do a couple more practice problems. This one, let's do together. And then the next one, I want you to pause the video and see how you do, and then compare your work with mine. So remember, first step is we want to factor. So this one factors, this one does not factor, and then this one actually does factor because it has a common factor of 4. So we have, remember also, we want to change this, so we're going to do plus and then -1. So we're looking to factor these now. We know that this is going to end up being plus -1 over x minus 3. And we know that there's a common factor of 4 for this, so we could say 1 over 4 times x minus 1. And so then we want to, for this quadratic, we want to find factors of 3 that add up to -4. That would be -3 and -1. So that is going to give us 6 over x minus 3 and x minus 1. All right, so then we can see that our common factor is that, or common denominator is, we have the common denominator of x minus 1 in 2 of these, and also x minus 3 in 2 of these rational expressions, and then the denominator of 4. So we're going to multiply everything by 4 times x minus 1 times x minus 3. So when we multiply it into the first rational expression, the x minus 3 will divide out, and we're left with 6. When we multiply it into the second one, we're left with -1 times 4, so -4. X minus 3 will divide out, so times x minus 1. And then when we multiply it into the second one, the 4 divides out and the x minus 1 divides out, and we're left with 1 times x minus 3, or x minus 3. So this is going to be a linear, so we're going to go ahead and just simplify, get rid of the parentheses. So 6 minus 4x plus 4 is equal to x minus 3. Get our x's to one side and get this 3 over here. So now what we have is 6 plus 4 is 10, plus 3 is 13, and 5x, divide by 5, and we get x is equal to 13/5. Now we want to check this up against our critical values. So that means we're going to look at x minus 1 cannot equal 0, so x cannot equal 1. And x minus 3 cannot equal 0, so x cannot equal 3. Since none of those answers are, neither of those answers or critical values are 13/5, we know that that's our answer right there. All right, so now here's another example problem. What I'd like you to do is to pause the video, go through the steps of solving it. Remember, factor first, simplify individual terms, multiply by common denominator, solve polynomial, and then make sure solutions are not any restricted or critical values. So go ahead and pause the video now, and then you can compare your work to mine. Okay, so as you guys can see, I labeled each rational expression as whether it will factor or not. So the first one is the only one that factors. So here it is in factored form. Then I identified my common denominator because I had t in these two, t minus 6. So t times t minus 6 is my common denominator, multiplying that out. Both denominator factors divide out for the first one, and we're left with negative 8. T minus 6 divides out for the second one, and so we're left with t times t. The t divides out for the third one, and we're left with t minus 6. So it's a quadratic. T squared minus 8 equals t minus 6, so we have to get it equal to 0, so we subtract negative t and add 6. And so we get t squared minus t minus 2 is equal to 0. We set this up to factor it. Negative 2, factors of negative 2 that add up to negative 1, negative 2, and 1. So we get our factors. Then we use the zero product property. And we solved, and so we get the solutions of t is equal to 2 and t is equal to negative 1. And then we look at our restricted or critical values, so t cannot equal 0 or 6. So then that would be our answer. And then I don't have my work showing this, but we get our critical values by taking our common denominator here, since nothing divided out, and we set it not equal to 0. Oh, sorry. T minus 6 does not equal to 0, so t does not equal to 6. And so that's where those restricted values came from. So this is basically the process of solving rational expressions.